Okay, this is question number 12 off the 2.5 worksheet number 2. Probably should have written that at the top. So 2.5 worksheet 2. And it's just asking us to evaluate a limit here as x approaches -3 of this pretty nasty complex fraction. We've seen a decent amount that have fractions in the numerator, like number 11, if you've got this worksheet right next to you. And I think we saw some on our notes like that too. This is a unique one, though, because it has fractions in the denominator. So, of course, the first thing we should try is plug and chug, but I think if we see that, we'll do that right away, we're going to see that we end up with what? A 1 over 0 and a -1/3 and a -3 on the top, and that 1 over 0, of course, is undefined. So not surprising that plug and chug isn't going to work, so we've got to try to be a little bit more creative here. What I think we're going to do is you really use the same strategy we use when we have fractions in the numerator. Now that we have them in the denominator, let's go ahead and let's try to get that common denominator and see if we can't clean things up a little bit. So in the denominator here, I'm going to multiply the first fraction by a 3 over 3 and the second fraction by a 3 plus, that was ugly, a 3 plus x over a 3 plus x. Don't need to do anything on the top. So that's going to give me now a limit still as x approaches -3 of, and here we go, just an x on the top. And now on the bottom, this 3 times this 1 is just going to be a 3. And then remember, guys, this is a -1 here that I'm going to distribute into that numerator there, that binomial. So that's going to be a -3 minus x all over that common denominator here of 3 times 3 plus x. Okay, now what's that going to do for us? I'm sure you saw right away that the 3 and the -3 are going to cancel each other out. This denominator of the denominator is going to move all the way up into the numerator. Remember, guys, that if we're doing something like a over b divided by c over d, that then becomes what? An a over b and then times the reciprocal of your denominator, d over c. So in this little example, it's just ad over bc. The point I was trying to make there is that the denominator of the denominator ends up going all the way up into the numerator and combines with the a. So this 3 times 3 plus x is going to get multiplied by this x right here. So we could rewrite this now as a limit as x approaches -3 of one fraction now, and the numerator is going to be this x times all of this mess. So I'm going to write that as a 3x times the quantity 3 plus x. And now, if I go back to my example in red up here, the final denominator here is the combination of these two factors right here. It's the denominator of the numerator and the numerator of the denominator. So this negative x that's left over here stays in the denominator, and there you go. Now what we have right here, guys, is that this x and this x will cancel each other out, but be careful, there's still a -1 down there on the bottom. So probably the easiest way to handle that would be to just take this negative and bring it right up here, make that -3, and then I can just completely forget about my denominator. And now, if I'm not mistaken, with no denominator, or really just a denominator of 1, this function is going to be continuous at -3. So that leaves us then with a -3 times 3 plus our new x value of -3. All that's going to become 0 times -3, and we should get 0 for our final answer there for problem number 12.